What we'll look at now is a stack implemented using an array as the backing store. Now, what you should notice if you've watched the linked list backing store clip is that this is a much more complex class. So we begin by allocating the array that represents the items in the stack. Now notice that we've allocated with a length of 0, and the reason I've done that is to avoid having to check for null later on. We can just check for length and find we have a length of 0. This makes the code a little more streamlined and avoids a special case. Now size is the number of items currently in the stack. This is not equal to the number of items that can be held by the array, or the array's length. This is the number of items currently in the array. So we'll start with push. And within push, there's a few cases we have to be worried about. The first is that size equals 0, and this is the case where we're doing our first push. The second is where size equals the current array length. This is a case where we've already added all the items into an array that we can, and we need to grow that array. In either case, the size variable will be equal to the length of the array, and then we'll go inside of the conditional expression. The first thing we'll do is figure out what the new length of the array should be. If the current size is 0, we'll default to 4. If the current size is greater than 0, we'll simply double the array. So if we had an array length of 4, it would now become 8. 8 would become 16, and so on. The next thing we'll do is we'll allocate the array based on the new length we've defined. Now this array will sit in parallel to our current array for a moment. We're going to copy all of the items from the existing array into the new array, and then we're going to point the items pointer to the new array. So now our array of items is the array we just allocated, which contains every item in our stack, plus an additional buffer space. So now we can add the new item into the items array at the index, and then we bump the index. Pop is actually pretty trivial. If size is 0, we throw, just like with the linked list. Otherwise, we decrement the size index and we return the appropriate item from the array. Peek is similar in that it throws if size is 0, but instead of decrementing size, it simply subtracts 1 while looking up the item. Count just returns the size. Clear sets size to 0. Now one thing to keep in mind, which I didn't deal with in this class, is that setting size to 0 doesn't clear out the array. Now for integers that's fine, but if this array contained disposable objects or objects that had finalizers, leaving them in that array would keep a reference to them alive. So if you're implementing a production quality stack, you're going to need to deal with issues like that. And this is one of the reasons that it's important to always consider using the stack provided to you by the platform you're on, because it should be taking care of these issues for you. The last things we'll look at are the enumerators. Now we're using the yield syntax as we enumerate over the items. The only tricky thing here is we enumerate the items backwards. And that's because the last item in the array is the first item we want to return. We want to return these items as if you had called pop, 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 pop. If we return them from index 0 up to size, they'll be returned in, first out order, not last in, first out order. And then the non-generic enumerator simply defers to the generic enumerator. So the class really isn't that complex, but compared to the linked list implementation, it's substantially more complex. But it should be clear that that complexity brings with it some performance improvements that are well worth it.